Let's go. Hey everybody, my name is Spencer Palmer. I'm here presenting for my group, which is Group 4, the Getters of Bread. And we're going to be talking about our project, which is First Glance, the facial recognition smart home device. So to kind of kick this off, we can start by introducing the team. First off, we have Thomas George, who is our project manager on this project. Next up, we have Harrison Hill, who is our documentation lead. Next up, we have Eric Galicia, who was our hardware lead for this project. And then lastly, we have me, Spencer Palmer, who was our software lead. But now we can talk a little bit more about the project itself. So what we did was we created a facial recognition security camera. And originally we had planned on going more on the doorbell side of things, but in the end we decided that creating this as a standalone device would be a little bit more versatile. And essentially what it's going to be doing is once the motion sensor is activated, it'll be running. If it does not recognize the face of the person, then it'll alert the owner and let them know that there's an unknown person outside the door. And if it does recognize this person, then it'll be capable of connecting to other IoT and smart home devices, and it'll allow the user to set preferences for those devices based on their arrival. So we know that there are other products out there that have cameras or other smart devices with cameras. But what we didn't see a lot of was the inclusion of a facial recognition software. So we felt that by adding this extra layer between you and anybody else that could access your smart devices would be a little bit better of an experience, and we saw a lot of potential for the future in that. In terms of commercialization, if we were to continue working on this project, we felt like we would probably have to make an app and maybe a little bit better of like a housing unit. But in the end...
Hi, I'm Eric Galicia, and I'll be going over the components used throughout the project. First off, the Raspberry Pi 4 Model B. This microcomputer was chosen over earlier generations of Raspberry Pis for its improved processing power that was necessary for our facial recognition needs, as well as its small form factor that kept our design relatively small and discreet. Second is the PIR sensor, or the passive infrared motion sensor. This was chosen for its small size and cost effectiveness. And lastly, the Raspberry Pi camera. This was chosen for the compatibility with Raspberry Pis and its decent image quality for facial recognition applications, as well as its small form factor. Now, here is a functional hardware block diagram of our project. Our microcontroller, the Raspberry Pi 4, is powered through a DC power source, and it gets digital signals from a motion sensor to start the program, and digital signals from a camera to do the facial recognition. It transmits this data to your home network, to other hardware in your house, like IoT devices like Alexa, Google Home, or any other smart device that you have in your home. Here is a software block diagram of our project. At the beginning, whenever the device is plugged in, the system is given a couple seconds to initialize and get the programs up and running. After the motion sensor is activated and triggered, the camera is initialized and starts searching for faces. If a face is not recognized, it goes back to the beginning of the code after a certain amount of time to begin only searching for motion. If a face is recognized and it is a owner or a person with a preset profile for what they want their routine to be whenever they get home, then it does that routine with their smart devices, say turn on the lamp, turn on the TV, do something with Alexa, and then it does that routine and goes back to the beginning of the code and searches for motion. If the person is not recognized by the system as an owner or somebody with a profile, it will alert the owner through an Alexa notification or Alexa sound notification inside the house.
The program starts with the trigger of motion sensor. Once the motion sensor triggers, it turns on the camera, identifies the person by comparing existing data of faces in the system. If recognized, the system will automatically trigger the other IoT devices according to the individual that has been identified as preference. If the individual is not recognized, it will alert the homeowner. Once the individual is recognized, it will go back to its dormant stage, waiting for the motion sensor to activate again. As you could see in the picture on the left, it is triggered by the motion sensor, identifies a person, and does the action each individual prefers. Then in the middle picture, you can see it recognizing my teammate Eric and I, then sending a notification to the phone. In this demo, I'm identified as the homeowner. In the example, when my face is recognized, The light gets turned on and Amazon Alexa announces that I'm at the door. Since I'm the homeowner, we do not have it sending a notification to the phone.
1.
Thomas is at the door.
Eric in this scenario is identified as the roommate of the homeowner. When Eric is recognized, it turns on the bedroom light and sends a notification to the homeowner.
Go.
Spencer in the scenario is a person that is not registered in the system. So when Spencer's face is identified, it notifies the homeowner by sending a notification to his phone and Alexa. This lets the homeowner know an unknown person is at the door.
Go.
Unknown is at the door.
Hi everyone, my name's Harrison Hill and I'll be going over the contributions of everyone on the project. So Eric was our hardware lead, and in that role he was in charge of making the final decisions regarding which specific components were used, as well as ensuring that they were implemented properly. He also worked on the facial recognition as well. I was the documentation lead, so I kept track of all of our assignments and reports, and I also worked on connecting the smart devices to the facial recognition, mainly through if this then that. Thomas was our project lead, and he was responsible for delegating tasks based on each member's strengths, as well as making sure that we were on track to meet all of our deadlines. He also worked on the facial recognition. And then Spencer was our software lead, and he was mainly in charge of the IoT / if this then that portion of the project. Overall, our costs were relatively minimal. We did end up having to replace our Pi camera a couple of times, and we also went through a few of the PRI sensors as well. But the total cost ended up being around $181, give or take a little bit. It is worth noting that that price is also variable because it's dependent on how many and which specific smart devices are being connected. So in our case, we only connected the Alexa and the smart bulb. But if you wanted to add more, then obviously the cost of that would go up as well. Moving on to the lessons we learned. So early on in the project, we had to learn the same skills that probably most groups had to learn, such as how to delegate tasks, how to create our own schedule, as well as like how to research and select appropriate components. And then I think our biggest takeaways came throughout and later on in the project, as there's definitely a learning curve when it came to sticking to that schedule that we had made. I think when we first made it, we definitely didn't have the most accurate ideas of of how long things would take. So that was definitely something we had to learn. And then at one point, we also lost the bulk of our project to a corrupted SD card. So that also taught us the importance of something as simple as just backing up our files. Finally, we have our future plans, most of which are ideas that we thought we would have time to incorporate in our final product, but as it turns out, we just couldn't get to them. So for our project to be an actual product, we understand that we would need like a mobile app or something similar to serve as a user interface instead of having to hook up the Pi to a monitor and do it that way. Um, and we could also incorporate other features such as live access to the camera, a microphone, stuff like you see with like Ring doorbells and stuff like that. And then the facial rec is understandably much less consistent in poor lighting. So incorporating a light on our product would also be beneficial. As far as data storage goes, we also wanted to look into using cloud computing for storing all the data collected, which I also think would be much more secure than storing it on the Pi itself. And then lastly, our prototype housing unit can of course be improved and refined.